Alright, good morning class. We're talking about probability today and the likeliness of certain events happening. So, very applicable to real life. We talk about this all the time with weather, the percent chance that it might rain. It's the probability that it's going to rain or snow in our case in Minnesota. So, let's talk about some terms. A lot of terms here that we need to write down. Probability of a simple event. So just one event happening. Here's what we need. Outcomes. Okay. Whatever can happen is an outcome. So, for instance, rolling a die, the outcomes are 1, 2, 3, 4, 5, and 6. Those are the possible results. We can get a 1, we can get a 2, a 3, a 4, a 5, or a 6. And so a simple event is one outcome or one group of outcomes. Alright, so we're looking for a certain set of these numbers. For instance, what's the probability of rolling even? Okay, that's a simple event. It's a group of numbers in one. The probability is the ratio that compares what we want to all the possible outcomes. Alright? So the probability of an even getting rolled on a die, well, how many evens are there? 2, 4, and 6, so there's 3 evens. Oh, gotta change the color. There's 3 evens out of how many possible numbers? Total possible outcomes is 6 on the bottom. So this would be, the probability would be 1/2. We reduce it down, or we could change it to 0.5, or we could change it to 50%. Okay? So we can do all sorts of things, or write it a whole bunch of ways. On this chart here, our percent can go anywhere from 0 to 1. Alright? 0, it can't happen. That'd be like me asking, if you roll a die, what's the probability of rolling 15? Okay, can't roll 15 on a die, there's only 6 sides. Certain is saying, what's the probability of rolling a number 1 through 6 on a die? Well, that's certain to happen. You're going to roll a number either 1 through 6, somewhere in there. 50% means it's just as likely not to happen as it is to happen. So we just got that even is 50%, right down the middle. Okay, so it could roll an even, could roll an odd, 50-50. Alright, so here's the more ones. A bag contains 7 pink, 2 white, and 6 blue marbles. If you're picking a marble without looking, find the probability of each situation. So P means probability, so this means probability of drawing a blue. Okay, so the top part of my fraction is however many blues there are. Well, that's 6. Over the total number of marbles in this bag. So I add them all up, I get a total of 15 marbles, because I could draw one of the 7 pinks, the 2 whites, or the 6 blues, so 15 total. And I want to reduce this down to 2/5. 3 goes into both of them, like that. And so I can leave it as a fraction. I can turn it into a decimal, which is 0.4, or I can write it as 40%. Whatever way they ask you to do it, we are able to oblige. Alright, what's the probability of not blue? Well, count all of them that are not blue. 2, 7, 9. 9 are not blue. There's still a total of 15 in there. Like that. Reduce this down. 3 goes into both of them, so it's 3/5, which equals 0.6, which is 60%. Now notice here, this is not a coincidence. If you find the probability of something happening, and also the probability of not something happening, the two numbers should add up to 1, or 100%. Okay, so this is 40%. The probability of not happening is 60%. Alright, so there's a 30% chance of snow. That means there's a 70% chance that it doesn't snow. Okay, so it has to add up to 100%, or the decimal should add up to 1. Okay. This is called the complement. The complement is something that it does not belong to. So the complement means not. Okay, so you can write down the definition, but make sure you emphasize the word not. Okay, so if it's not going to happen, it's the complement. A sample space. This is a way to collect all the possible outcomes, especially if you have more than one thing going on. Okay, so when we roll a dice, we said the outcomes are 1 through 6. But what if we roll a dice and we flip a coin both? Okay, so now I have to take both into consideration. So when I roll my dice, I can get 1 through 6. When I flip my coin, what can happen? Well, I can get heads or tails. So I now have 1 through 6, and I can get heads with all those. And I have 1 through 6, and I can get tails with all those. So now there's 12 possible outcomes in my sample space. Okay, right there. Does that make sense? You get 1 through 6 on the dice, and you get heads or tails on the coin. And now they want to find the probability of getting an even and a heads. Okay, so I go through my chart looking for evens and heads. Oh, there's an even and head. There's an even and a head, and then there's even and a head. So there's 3 of them. 3 out of 12 reduces down to 1/4, which is 25% or 0.25. All right. So there's lots of other possibilities we could ask you for probability. We could ask for, a prime number and a tail. We could ask for a number greater than 5 and a head. All sorts of possibilities. So if you make a sample space chart, you can just kind of pick which ones we're looking for based on that chart. Alright, now this is what the title of the chapter or the section was: Theoretical and Experimental Probability. Theoretical is what we expect to happen or what should occur. Okay, so kind of like the weather. It should rain or it shouldn't rain a certain day. Rolling a dice, there's a 1 out of 6 chance of rolling a 1. That means every 6 rolls we should roll 1/1. But we also know that doesn't happen. We also know the weathermen are wrong. We also know we can roll 1 in back-to-back rolls. Alright? So theoretical is what we think should happen or what we expect to happen. Experimental is actually what does occur. Okay? So if we're actually doing an experiment and we write down all the numbers that are rolled on a dice, that's the experimental probability. Alright? So let's compare the theoretical and experimental of rolling a dice. Alright? So here's what happened. They rolled the dice here. How many times did it say they did it? 29? Yeah, 29 times they rolled the dice. They got a 1 4 times, 2 was 6 times, 3 was 2, 4 was 8 times, 5 was 3, and 6 was rolled 6 times. So they want to compare the two. Well, if I roll, what we're looking for? A 6. Okay, sorry. Looking for a 6 here. I would expect to roll a 6 1 out of every 6 times. Okay? We just talked about that with 1. So that's the theoretical probability. That's what I would expect to happen. Now the actual probability is, well, I rolled 6 out of a possible 29 chances. So the experimental is 6 out of 29, which is around 21%. Alright? This is 17%. So when it just says compare, it just means find the two. Okay? And if this one's bigger, we rolled a 6. You say we rolled a 6 more often than we expected. Or if it was smaller, we'd say, well, we rolled it less often than we expected. Okay? Like a 3. We rolled a 3 less often than we probably expected. Alright? Odds. This is where we get a little confusion sometimes. Okay? So, probability, we do what we want over the total possible. Odds, in favor, we do what we want compared to what we don't want. Okay, so that's where that complement kind of comes in. What we want, what we don't want. Odds against is what we don't want compared to what we want. Okay? So, if we roll a die, what are the odds in favor of rolling a 1 or a 2? Well, to roll a 1 or a 2, there's 2 numbers that fit that criteria. And then the second number in our ratio or our comparison is what we don't want. Well, we don't want a 3, 4, 5, or 6. So there's 4 numbers we don't want, which means we reduce this down to 1 to 2. Okay? So odds are not that fraction out of the total. It is what we want versus what we don't want. Or if it's odds against, it's what we don't want compared to what we want. Alright? So here's another one. Die as well, what are the odds against rolling an even number? Alright? So odds against mean what we don't want. Well, that means we want odds, or we don't want odds. So 1, 3, and 5. There's 3 odds. And what we want are even. So our fractions flipped around, although it doesn't matter for this one. Because odds against, you want what you don't want first. This reduces down to 1-to-1. Alright, one last thing here. This is kind of on the review for the chapter test. Setting up a proportion here. We have a chart of people that do certain activities, teens that do certain activities, and they want to know if there's 450 teens surveyed, predict how many listen to music. Well, 26% listen to music. 26% means 26 out of 100. I want to predict how many I would expect out of 450 people. Well, how many would I expect out of 450? Okay, so it's part over whole equals part over whole. What part of the whole group is equal to 26% or 26 out of 100? Well, then I'm going to cross multiply here. 26 times 450 is 11,700. 100 times x is 100x. And now I solve this equation by dividing by 100 to both sides. So I would expect it to be 117 when I divide by 100 there. 117 people listen to music. Alright, I know it's a lot of information for you, but again, the biggest thing is probability. You know, what you want over the total. If you're getting some odds, remember it's what you want compared to what you don't want, or vice versa if it's odds against. But probability, very useful stuff. We ask a lot of it on tests. You run into it in real life. You know, later on when you're able to gamble, probability comes into play a lot. So maybe make you some money someday. Have a wonderful day of school.